Hi, today we're going to talk about the distributive property, but first I think it's important to talk about a few other properties that we've discussed that you guys learned in other grades. So the first property we'll start to talk about is the commutative property. And when we're talking about the commutative property, what we're actually talking about is changing the order of the numbers in the problem. So a good way to remember this is with the C and with the O. The C represents change, and the O represents order. So if we were going to look at this, we would be talking about changing with the C and the order with the O. Another great way to remember this is to think about the word commute. Now, if you don't know what the word commute means, commute basically means to travel some distance between one's home and where they work on a regular basis. So let's talk a little bit more about what the word commute means. So let's say that your uncle lives at this house and he drives all the way over here to his office here, and it's about a total of 10 miles. So the distance from home to his office is 10 miles. Now your uncle and Mrs. Whippick have something in common. Both of them love coffee. So your uncle stops every morning to get some coffee at his favorite coffee shop right here. Let's say that the distance from home to the coffee shop is about 4 miles. So each morning he drives this distance to the coffee shop to get his morning coffee, and then he takes the rest of the way to work, which if this from here to here is 4 miles, and we know the entire length is 10 miles, how much more does he have to go to get to work? If you said 6 miles, you're right. So let's demonstrate this. Here is your uncle, and he's driving 4 miles to work. He's commuting on his way to work, but stopping at the coffee shop. He gets his coffee, and then he drives the other 6 miles to get all the way to work. Now, your uncle has spent a long day of working, and he is ready to go home. However, he decides he's going to treat himself to some more coffee. So he drives 6 miles from his office back to the coffee shop, and then another 4 miles from the coffee shop to home, for another total of 10 miles. Now, we talked about how the distance from work to home and from home to work is a total of 10 miles each, so for a total of 20 miles. So it doesn't matter which way we're going, whether we're going from here to the coffee shop and then the rest of the way to work, or from work to the coffee shop and all the way home. It's always going to be a distance of 10 miles. If we were to write this as an equation or an equality, we'd say that your uncle drove 4 miles plus 6 miles to get to work, and then he drove 6 miles plus 4 miles to get back home. If we were writing this as the commutative property, we would write it as 4 plus 6 is the same as 6 plus 4. Both sides are equal to 10. It's just that we're changing the order of which we're putting the numbers. So here the 4 is first and the 6 is second because we're commuting to work, and then we're commuting back home 6 miles to the coffee shop and then 4 miles home. That's also a distance of 10 miles. So let's look at a number example. And it doesn't always have to be small numbers. Obviously, you can use any size number you want. But if we said that we were going to drive 5 miles to the grocery store, plus another 12 miles to work, and then, of course, we have to go back home, but oops, we forgot something at the grocery store, so we have to stop at the grocery store. So we start at work, and we drive 12 miles from work to the grocery store, plus another 5 miles home, we're still driving the same distance of 17 miles. And this is called an equality because both sides of the equal sign are the same amount. They have the same value. So when we talk about both sides of the equal sign having the same value, that is called an equality. And we consider this equality to be part of the commutative property because we're changing the order of the numbers. Now, we don't just have to use this with addition. We can also use this with multiplication. So let's look at that. So here's an example of using multiplication with the commutative property. So once again, we're changing the order when we're talking about the commutative property. So let's think of two factors. Let's say 3 and 5. We have 3, and then we put our times sign, and we write 5. That is exactly the same as changing the order of the numbers and saying 5 times 3. 3 times 5 has a value of 15, and so does 5 times 3. This is an equality because both sides are the same value as each other. Now, would this work with subtraction or with division? Let's see. So let's take subtraction first. If we were to write 10 minus 6, that value would be 4. Now, if we flipped the numbers, we changed the order of the numbers like we do in the commutative property, we'd say 6 minus 10. And that is not the same value as 4 because we actually end up going into negative numbers. So if we start at the number 6, so we have 1, 2, 3, 4, 5, 6, and then we subtract 10, we'd go 1, 2, 3, 4, 5, 6, now we're at 0, 7, 8, 9, 10, and this ends up being negative 4. So negative 4 and 4 are not the same value. Same goes for division. If we were going to demonstrate the problem 16 divided by 2, we would see, okay, I can't make any groups of 2 with this one, but I can make a group of 2 with 16, and that would be 8. So, okay, so 16 divided by 2 is equal to 8. Now, let's try 2 divided by 16. So we're doing this problem now. I can't make any groups of 16 if I only have 2 things. So now I'm going to have to go into decimal places. And we'll learn more about this year, but we can't even make one whole here if we only have 2 things. So it's going to be even smaller than 1, which is obviously not going to be the same thing as 8. So just to recap, the commutative property does not work with subtraction or with division. It only works with multiplication and with addition. So now let's talk about the associative property. When we talk about the associative property, we can also use a keyword that's included in this term to help us understand what it means. So if we were to look at this and we looked at the word associative, it sounds very much like the word associate. And looking up the word associate in the dictionary, you'll find that associate means to come together with friends, business partners, or companions. And some synonyms, or in other words, words that mean the similar thing or something close to the same, we could also say that associate is closely related to the word mingle, mix, and relate because they have similar definitions. So what does this associate have to do with the associative property and using it in math? Well, if we said that associate means to come together with friends, business partners, or companions, we need to think about, let's just use the example of some friends here, some little kids. So we have 6 friends here total, right? So we have 1, 2, 3, 4, 5, and 6 people. Now, let's say that they're all going out for recess, and these 3 guys right here are best friends. So we'll say that these 3 guys are best friends. These 2 people are really good friends. And then we have this other person sitting off to the side. All by herself. Now, we still have the total of 6 people here, right? So we have 3 people plus 2 people plus 1 more person. We still have a total of 6 students. Now, the associative property means that we're going to come together or group with each other. We're going to mingle with each other. So let's say that today at recess, these 3 friends decide that they want to hang out with these 2 friends. So we're going to say these 3 friends plus these 2 friends are hanging out together, and then this poor girl is still off to the side all by herself. Now we still have a total of 6 students because we haven't lost or gained any, but they're just hanging out differently. We have these 5 kids right here hanging out together. They're associating with one another. And then we have this poor little girl off by herself. She's still on the playground. She's still a student in the class, but she's all by herself. Now, when we talk about the associative property, what we're talking about is grouping them differently. So instead of grouping them like this, let's group them a different way. We're still going to have the same groups of friends because they're all best friends. So these 3 are best friends, these 2 are best friends, and then this little girl's off by herself. But let's say today at recess, these 2 little guys right here decide that they want to hang out with this little girl instead of hanging out with these 3 kids. So yesterday when they were playing, we had the group of 3 plus the group of 2, and then 1 student off by herself. Now this would be a total of 5 plus 1, which would equal 6. Now today they're deciding to group differently. These 2 kids right here are going to hang out with this one, and these 3 are going to stay together. So let's write that as the dissociative property. So we still have the same 3 kids, the same 2 kids, and the same 1 kid to equal 6, right? But now these guys are all hanging out together. So these friends are going to associate with one another. Do you see how we still have the same numbers in the same order, the same kids in the same order, but now instead of these 5 friends hanging out together like they did yesterday with this girl off by herself, today these 3 kids are going to hang out together, and these kids are all going to hang out together in a group. They're associating with one another. Okay, so that's what we mean when we talk about the associative property. Let's do one more quick example. So let's say that these 2 guys right here are best friends, okay? And then these 2 people right here are really close friends, and then we have this little girl. She's still happy. She's all by herself, but she's smiling because she's flying her kite, and she's off by herself. So we have a group of 2 right here. We have another group of 2 right here where these 2 friends are, and then we have 1 person off by herself right here. Okay, so we're going to write this on both sides of the equal sign. So we have the same 2 friends plus the same 2 friends plus the 1 person. Now, let's say on Monday at recess, these 2 friends decide to hang out with these 2 friends. So we would group them in parentheses because that means that they're associating with one another. They're mingling. They're coming together with friends. So they're mingling on this day, and that would mean that we have a total of 4 people plus 1 person, 1, which equals a total of 5 people, right? Now the next day, these 2 friends over here decide they want to fly a kite with this little girl. So we're going to group them. So these 2 friends right here in the middle are playing with the kite with this little girl. Now we still have the same number on both sides. We have the same value, which is 5 and 5. So we know that this is an equality because both sides of the equal sign are the same value. So let's look at it now in terms of multiplication. So let's say we have 3 times 2 times 4. Well, if we were to take this and solve it, we would first look at these and we'd say 3 times 2 is 6. Now I have to copy the rest of my problem down because I can't, ignore these numbers here. So 6 times 4 would equal 24, okay? So let's write this down here. If we were going to write this as the associative property, we'd have to make sure that we put the numbers in the same order, but this time we're going to group the numbers. We're going to have them associate with one another. They're going to mingle. So this time we're going to have these 3 and 2, 3 times 2 work together, and then off to the side, they're still going to multiply it times 4. On this side, we're going to have the 3 off by itself, multiplying itself times the 2 and the 4. So once again, when we're talking about the associative property, we mean that we're grouping the numbers together because we are associating different numbers, okay? So we're associating different numbers together. Now here comes the property that we just started learning about this year. So this is now a 5th grade property that you will expand on in middle school. So what exactly is the distributive property? Well, once again, we're going to look at a part of the word distributive in order to try to make some sense of what the distributive property means. So when we look at the word distributive, we can see that in there's a word we kind of are familiar with, which is the word distribute. And when we talk about distributing, we mean giving out shares of or dealing out something. So let's say we have 2 little friends here, and we want to distribute some candy to them. We want to give equal shares of or deal out some candy to both of these friends. And we decide that we want to give each child 4 bags of candy. After we've distributed candy to the 2 kids, we find that this child has 4 bags of candy, and this child also has 4 bags of candy. So basically what we did was we said we're going to take 4 bags of candy and we're going to give it to 2 people. So we have a total number of how many bags of candy? 8. Okay, so we had 4 bags of candy times 2 equals 8. Let's talk a little bit more about distributing. So let's say that you and your 3 friends decide to go to Chick-fil-A night at school. So you each order 2 chicken sandwiches and an order of French fries because you are hungry. So the question for this problem is, how many total food items do you all purchase in all? So we had you and your 3 friends, which is a total of how many people? 4 people. So here's you, and here are your 3 friends. And each of you are getting 2 chicken sandwiches and 1 order of waffle fries. So how many total food items, we're not talking about individual chicken sandwiches or French fries, we're talking about the total number of food items that we purchased in all. So if we were to count these out, we'd say, okay, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And we could write this as, we have 4 people times, and each of them is getting, and when we have a number right next to this parentheses, it means times. But we have 4 people, each of them are getting 2 chicken sandwiches and 1 French fry, right? And so if we were to add these up, we would say this is 3, and then our entire problem would end up being 4 times 3 equals 12. Now, this has something to do with the distributive property because we took these 4 people, and we distributed some food to each of those 4 people. We distributed 4 people to 2 chicken sandwiches and 1 order of fries. So it might not be 100% clear right now what the distributive property means, but let's go into more depth. So the distributive property helps us find a product, which is the result of a multiplication problem, remember? So it helps us find a product that we don't know by breaking larger factors into smaller factors. And if you'll recall your vocabulary, factors are the numbers we multiply together to get a product or the answer of a multiplication problem. So let's look at this problem again. So earlier we said that we had 4 friends, right? And that would be, or I'm sorry, there were 4 of us. So it's us and then 3 friends, which is a total of 4 people, right? Now, if we were just going to talk about the number of food items, we could have just said 4 times 3 food items each person equals 12. But we broke apart one of these numbers, which was the 3, into specific food choices. We said we each were getting 2 chicken sandwiches plus 1 waffle fry order. So 2 chicken sandwiches plus 1 fry order equals 3 total food items, which is right here. So the 2 plus the 1 is equal to the 3. So remember, we just talked about how the distributive property allows us to break one of our factors, which are these 2 numbers, into 2 numbers and then multiply them. So what we did was we said, okay, there are 4 people and they're each going to get 2 chicken sandwiches and 1 waffle fry. So if we were to write this out again, we'd say, okay, 4 people times 2 chicken sandwiches, so that's this amount here, plus 4 people times waffle fries, 1 waffle fry each, okay? So we have 4 times 2, which we know is 8, copy down our plus sign, and then 4 times 1 equals 4. So we get the same answer even though we wrote this up here as 4 times 3 equals 12. We get the same exact answer if we break one of our factors, only one, into 2 separate parts. So in this case we did 2 chicken sandwiches plus 1 equals 3 food items, okay? So do you see how we took the 4 times the 3, we broke our 3 food items into 2 separate types of items, so we had the chicken sandwiches plus the french fries, and then we had our 4 people eating these. Now, in this case, we took our 4 people and gave them each 2 chicken sandwiches, and then we gave those 4 people 1 order of french fries. We added up those amounts, which is right here, 8 chicken sandwiches plus 4 french fries equals 12 food items. Okay, so let's try this again, but this time using just numbers. So let's say that you were asked to solve the problem 7 times 7. Now, when we use the distributive property, it can help us if we don't know all of our math facts because we can break one of our factors into 2 smaller factors that add up to that number. So let's take the second 7 here and let's break this apart into 2 factors. I'm pretty good with my 5 times tables. And then in order to get to 7 with 5, I'd need to add 2 more. So I'm going to break my 7 into 5 and 2, okay? So now we've rewritten this problem as 7 times 5 plus 2. And when we talk about numbers being in parentheses, sometimes you'll hear people refer to this as 7 times the quantity of 5 plus 2, and the parentheses are the quantity. All right, so let's go a little bit further. So we're going to distribute this 7 right here to these 2 numbers over here. So let's take that 7, and first we're going to use this 5 because we don't want to multiply times this 7 anymore because I don't know my 7 times tables as well, but I do know my 5s. So if I were to say 7 times 5, and then I have to do my 7 up here again times my 2. So 7 times 5 I know equals 35. And 7 times 2 equals 14. Now, I've taken this number 7 and I've multiplied it times both of these numbers because I had to distribute it times 7 times 5 and 7 times 2. But I'm not done, because I have 2 different numbers and it's not my answer. I have 2 different answers. What I have to end up doing is adding these together. So 5 plus 4 equals 9, and 3 plus 1 equals 4. So my answer, and actually it's 30 plus 10 equals 40. My final answer is 49. Now, if you knew your 7 times tables and you could do 7 times 7 equals 49, that's wonderful. But the distributive method helps us to take factors and break them apart into smaller numbers. It might seem kind of silly to do this with our math facts that we know by heart, but it actually becomes very useful when we talk about multiplying larger numbers. Let's look at an example. Okay, let's do 3 times 24. Now, I don't know about you, but I don't have my 24s memorized. I don't have my times table of 24s memorized. So what I'm going to do is I'm going to break this larger number apart here into two smaller numbers that add up to 24. And I actually really like my tens times tables because I know that all I have to do is add a 0. So I'm going to break this into tens, which there are 2 tens in 24, plus 4. All right, so I've just broken my 24 into 20 plus 4. Now, I still have to multiply this amount times 20. Now we're going to rewrite the problem. We know that we have to distribute this 3 right here to each of these numbers inside of the parentheses. So let's write it. We know we have to distribute the 3 2 times because there are 2 numbers inside of the parentheses. The first number we have to multiply it times inside is 20. And then the second number we have to multiply it times is 4. Now, when I do my multiplication of my 3 times my 20, I just look at the first number in this here, in this double-digit number, and I say, okay, 3 times 2 equals 6. Now I have to add a 0 onto the end because 20 has a 0 at the end. It's not just 2, it's 20. And then I know that 3 times 4 is equal to 12. Now I'm not done because I have 2 separate numbers that I need to add together to get my final answer. So my final answer is going to be 72. 3 times 24 is the same as 72. So let's look at some different ways to write this, the distributive property. So we have 3 times 24 again. So we could write it as we just did, as 3 times the quantity of 20 plus 4, because we broke the 24 into 20 plus 4, okay? We could also express this as distributing the 3 to the 20 and again to the 4. So we know that if we're multiplying 3 times the stuff inside of the parentheses, it would be 3 times 20 plus sign, because we have to add up the different amounts, 3, we're distributing now the 3 to the 4. This is another way of expressing the distributive property. And there's yet another way that you could express an equation into this distributive property. And that is, you could take any of these up here. You could take this one, you could take this one, or you could take this. And let's just choose one. We'll do the one right here. 3 times 20 plus 4 equals, and then remember on the last example we said it was 60 because 3 times 20 is 60. And then we have to do our plus sign, because that's right here. And then we have to distribute our 3 times, the parentheses right next to the number means times, 3 times 4. So 3 times 4 equals 12. So you could also express the distributive property with the numbers that you have broken it apart into the products of those two numbers. So first we have the product of 3 times 20, and then we have the product of 3 times 4. All right, so let's do another example. Once again, you can use the distributive property with any multiplication problem that you have large numbers in that you don't know the times tables for. So let's think of another one. Let's say it's 4 times 36. Now, I personally always like to break up the bigger number because I don't have my really large times tables memorized. So that means in this problem, we're going to break apart the 36. And I always find it to be most useful to break the larger numbers into tens, which is this place value, and the ones, which is this place value. So when we're talking about breaking 36 into tens and ones, we have 30 plus 6. We have 3 tens, which is 30, and 6 ones, which is the 6, okay? Now we still need to take that and multiply it times 4, because that's the number that we have here 4 times. Remember, we said that a number right next to parentheses means multiply, so we actually don't need to put the times sign in between here. We can just have the number right next to the parentheses, okay? So now we're going to do our distributing. We're going to distribute the number on the outside of the parentheses to the numbers on the inside. So first we're going to take our 4 and distribute it to the 30. And once again, 4 times 30. So 4 times 30 written out. And I know that 4 times 3 equals 12. And then I just need to add a 0 on because I need to multiply that total times the 10. Because it's not 3, it's 3 times 10, 30. Now, my next one, I have to take my 4, distribute it to the 6. So 4 times 6, and that equals 24. Now, am I done? No, because I still have 2 numbers listed here. I need to add these 2 totals up, and I get 144. That is so much easier than having to write out 36 times 4 and doing it this way. Now, if you prefer the other method, that's great, but you will be required to know what the distributive property is for tests and in middle school. So what are some of the ways that we could express this problem that we just did in the distributive property? Well, we could do 4 times 36 equals 4 times, and then we broke it into 30 plus 6. We could also say that it's 4 times 30 plus sign, and then we have to distribute the 4 times the 6. And remember, they will try to trick you on tests because they will put plus signs in here instead of multiplication signs. That's going to give you a completely different answer than if you were to use the multiplication signs. We could also say that these things equal 120 plus 24. Now let's look at this array. This array, we use arrays when we talk about multiplication, right? So when we talk about multiplication, we mean if we said this was 3 times 7, it means that we have 3 rows, which is a cross, right? Rows. It means that we have 3 rows, and in each of those rows, there are 1, 2, 3, 4, 5, 6, 7 things, okay? So 3 times 7 means 3 rows, 1, 2, 3, with 7 different tiles in each, okay? Now, once again, we talked about how we usually would want to just do the multiplication on smaller problems like this, but in order to save myself from having to make 144 little squares, we're going to break this apart into a simpler problem and just demonstrate with small numbers. So if we were going to take this and break the 3 times the 7 apart, I like my 5s personally, so I would want to break this apart into 3 times 5 plus 2, because 5 plus 2 equals 7, right? So we're doing 3, and then instead of doing an entire 7, we're saying 5 plus 2. So what would this look like? So here's what it would look like. We started with 3 times 7, right? we broke our 7 into 5 and 2. Now, we said we had 3 rows. We still have 3 rows, do you agree? Because we have 1 row, 2 rows, and 3 rows. But instead of having 7 altogether, we now have 3 rows of 1, 2, 3, 4, 5. So there's our 3 times our 5, plus 3 times 2. We still have 7 all the way across. So we still have this 1, 2, 3, 4, 5, 6, 7 all the way across. But instead of having 7 all together, we've broken it apart into 2 different arrays. We've broken it into a 3 by 5 array. And we're adding it to a 3 by 2 array because we have 3 rows with 2 in each row. That's the 2, okay? So now, if we were to figure out how many tiles or squares are in this, we'd say 3 times 5, 3 rows of 5 tiles each equals 15 tiles, plus on this side we have 1, 2, 3 rows times 2 tiles, which gives us a total of 6 tiles. So 15 plus 6 equals 21. So let's look at that again. We have 3 times 7. The 7 doesn't want to write. Okay, we broke the 7 apart into 5, 1, 2, 3, 4, 5, plus 2, 1, 2. But we don't just have 5 and 2, we have 3 rows of that, of 5, and 3 rows of 2, okay? So that's why we say 3 times 7 is the same as this 3, parentheses means times and distribute, 3 times 5 plus 2. So these are the same. It's also the same, once again, as 3 times 5, 3 rows of 5, plus 3 rows of 2 each, okay? And we could also write it as 15 plus 6. So now let's take a look at some problems you might expect to see on a standardized test like the SOL, or even on a test in your own classroom. Alright, so let's take a look at some different problems you could expect to see on a standardized test or on your own test in your classroom. Here's the first one. Which equation shows the use of the distributive property? First thing I always do is I underline or highlight my important information. So in this case, I know that I'm looking for the distributive property. Now, I'm going to look at each of the options and see if I can identify any other properties here that they might be trying to trick me with. So let's see. I know that this one right here has the numbers in the same order, 7 times 6 times 4 and 7 times 6 times 4, but they're grouping or associating different numbers together. So what I'm going to do is I'm going to put a little A next to that so that I know that that's an example of the associative property, and then I'm going to X this one out because I know that's not the distributive, it's the associative. All right, so let's look down here. Oh, 4 times 5 times 8 and 5 times 4 times 8. Those are the same numbers, but they're changing the order. So I'm going to write a C next to this one because I know that that's an example of the commutative property. Now let's look at the remaining 2 options. The first one says 12 times the quantity of 4 plus 5 is equal to or the same as 12 times 4 plus 5. Well, let's see if that's true. Let's go ahead and solve this one off to the side. So 12 times the quantity of 4 plus 5 is equal to 12 times 4 plus 5. Okay, let's see if that's true. Let's see if this is in fact an equality. So to use the distributive property, I just need to look here and say 12 times 4, and then I need to also multiply my 12 on the outside times my 5. So we say 12 times 5. Okay, so let's solve that. 12 times 4 is 48, and 12 times 5 is 60. Okay, so 48 plus 60, let's see here. That equals 108. Now, let's look at the other side of the number sentence over here. It says 12 times 4 plus 5. And using the order of operations, which we'll learn next week, we know that we need to do the multiplication first. So 12 times 4 is 48, and then we need to copy the rest of the problem down. So 48 plus 5 is 53. Wait a second. If this side over here is equal to 108, and this side over here is equal to 53, both sides are not balanced. This is not an equality. This is called an inequality because the sides are not equal to each other. They're not the same. So we know that letter A, is not an example of anything because it's not true. This is not a true statement that 12 times 4 plus 5 is equal to the same thing over here. The quantities, the parentheses change that because it tells us to distribute this number to each of those. So now let's look at the final one. We have all right, so here's another similar problem. Let's see if we can read the problem first. Which of the following is an example of the distributive property? We underline or highlight our important information. And now let's go through and see if we identify any other properties other than distributive. So we have 4 times 6 here is equal to 6 times 4. Well, it looks like we're just changing the order of the numbers. So this is going to be an example of the commutative property. So I'm going to mark that one off as no. At a quick glance, I'm going to look down here at letter B, 4, 6, and 10, 10, 6, and 4, and they're grouping. This doesn't look like it looks like it might be a combination of associative and commutative. So this is not it. Okay, so let's look at the next one. 4 times 6 plus 10 is equal to 24 plus 40. Let's see if that's true. So first we distribute our 4 to our 6 and we multiply. And then we have to add on this part. So we have to multiply the 4 times the 10. So 4 times 6 is 24 and 4 times 10 is 40. Oh, look. That is true. That is an example of the distributive property because this is equal to this. And we distributed our 4, so this is the answer. But let's look at the last one just to make sure. Okay, so the last one says 4 times 1 equals 4. That's an example of the identity property, so I know I've got the right answer. C is an example of the distributive property. Ooh, this one looks a little bit tricky. Let's read it carefully. Write the following expression as the distributive method formatted like A times the quantity of B plus C. Ooh, that's tricky. Okay, well, let's think about what I know of the distributive property. I know that A times B plus C is using some variables to represent it, right? But we've seen this kind of problem before when we plug in some numbers there. So if we plugged in some numbers here, what would go in those spots? All right, and here's our last one. Use the distributive property to complete the math sentence below. Oh, okay, so this is very similar to like what we just did, except it's backwards from what we did. So last time we took a problem that was already broken into this format and we turned it into this format. Now we're just going to do the opposite. So let's see here. Oh, they already have the first one done for me, so I just need to fill in what goes in this parentheses. So we said 6 times 4 plus 2 is equal to, and they already have 6 times 4 plus, now what needs to go in this set of parentheses? Well, let's look. We know that 6 is being distributed to the 4 here, but the 6 also needs to be distributed to this 2. So we're going to write, once again, the number in the beginning is going to be the same on both sides because we're distributing that 6. So we do 6 times 2, and we write times, not plus, because we're multiplying 6 times, that's what this means, 6 times the number on the inside, which is 2. The plus sign goes in between because we're adding these two totals together. Okay, so for our final problem, we read that the directions say to evaluate the following. And whenever we see that word evaluate, we know that it means solve. So we want to solve this problem, okay? So 6 times the quantity of 10 plus 2. Now, we could write this out, or we could draw some pictures. And I recommend writing out in number form, but I'm going to demonstrate what it would look like if we used pictures as well, okay? So it says 6 times 10 plus 2. So that means I have 6 rows. So 1, 2, 3, 4, 5, and 6. And in the first set of rows, I have 10 blocks. So I'm just going to draw 10 blocks here. Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9. Oh, that's pretty big. 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Let's pretend those are all even. Now, I don't just have one row of that. I have 6. So I'm just going to draw this on. So we're just going to add this on. So 2, 3, 4, 5, and 6. So there's 10 in each row. It's terrible drawing, sorry guys. Oh, I missed my applause in school. Okay, so we have 6 rows and each row has 10 in it, right? Now we're not done because we have to look at the other side of the plus sign and see what we need on this side. So we have 6 rows again, so 1, 2, 3, 4, 5, and 6, but each one now has to have 2. So it's going to look like this. There's 3 rows of 2, 4 rows of 2, 5 rows of 2, and 6 rows of 2. Okay, now if we were to add up all of the boxes on this side over here, we would find that we had a total of 60. And then we would add that to the 12 that are on this side. We could also write this as 6 times 10 on this side because we have 6 rows with 10 boxes in each. Then we have our plus sign, and then on this side we have 6 rows of 2 each, so we could write this as 6 times 2. 6 times 10 is the same as 60. 6 times 2 is the same as 12. So even though we've drawn this all out and we've written it in multiple ways as the distributive property, we're not done because the problem does not say write as the distributive property or put in distributive property form. It says evaluate, which we said means to solve. So we need to take our numbers down here, 60 plus 12, and we need to add them together, which gives us 72. So once we've evaluated this expression, we get the answer of 72. Alright, so I hope that's helped you a little bit on the distributive property. Please feel free to watch this video at any time. If you go on my math blog, there are a lot of resources for you to watch other videos that explain it and to participate in some activities that involve using the distributive property. If you have any further questions, please don't hesitate to ask me in class, and I will see you soon. Bye!